Hey everybody, in this video I want to talk about one more thing to finish the phase diagram question, part C, and then we'll look at the last two sort of interpretation questions. So last video we added the arrows and drew the diagram, but I think the one more thing we could add is showing the stability paths of different initial conditions. So we choose an initial k0, k hat 0, and 3 values of C, and we're just going to recreate the diagram from the book. And I think if we do it like this, you'll definitely get full marks. So remember that in Ramsey there's only one stable path in the model. So we'll call it C hat 2 in this case. And if they choose that level of consumption in the beginning, it will end up at the saddle point. You'll have forces pointing to it from both directions, so it can't really be overshot. Now for C hat 1, that's too high, so it's going to go up into this top quadrant and then crash into the y-axis, while C hat 3 is too low. It's not going to make it to the path. It'll pass into this quadrant and then crash into the x-axis. So I think that is the complete phase diagram. There's really nothing else you can add to that. So now let's look at the last two questions, because they're pretty brief. Question D says to suppose the economy is on a balanced growth path, so we're in the saddle path. And that's important because once we're in there, there's no reason we would believe that we would fall out. So it says something happens and our value of K falls. So let's say there's an earthquake that destroys half of the factories. So remember that in Ramsey we are constantly reevaluating our choice of C. We're not choosing once for all time. It's a continuous time function. So we're going to be along the balanced path, the middle C2 one. And then something's going to happen and we're going to go down to K star, 1/2 K star. So the people in the society will realize they are down to 1/2, so they're just going to rewind back to this point. They'll choose a level of C associated with K hat star, C hat 4, that will be on the balanced growth path on this saddle stable point. And then they'll get back to that K star, C star point eventually. So nothing else is changing, so nothing's going to shift, nothing's going to change. They're just going to go down and they're going to come back up. Let's look at the last question, part E, which says now to imagine an increase in the depreciation rate from delta to delta prime. So just like when we derived the arrows, we'll look at how that impacts our two equations and shift things accordingly. Here a parameter is changing, so we can probably guess that things are going to shift with delta prime is greater than delta. So let's start with the k hat dot equation. We have f of k hat minus k hat, minus k hat times delta plus n plus gamma minus c hat. That's going to be something compared to f of k hat minus k hat delta prime plus n plus gamma minus c hat. Okay, so this is small. This one is small. And we're going to multiply something small by something and then subtract it. So this is going to be relatively bigger. On the other hand, this one is going to be big. This delta is the big one. So when we multiply it, k hat will be relatively bigger. And when we subtract something big, we're going to get something relatively small. So big is greater than small. And so we find that the delta, compared to what we have here, the delta prime k schedule is going to be less. So the schedule is going to shift down. Getting kind of messy. Let me pick something really colorful. So the schedule is going to shift down to here, or wherever you want to draw it. Then we look at the C schedule. We're going to do the exact same thing. We have 1 over theta times f prime of k hat minus delta minus rho minus theta gamma. And that's going to be something in comparison to the delta prime. Same equation with delta prime. Prime of k hat minus delta prime minus rho minus theta gamma. So again, this is relatively small, and something small minus something is going to be relatively big, whereas this one is relatively big, and something big minus something will be small. And again, big is greater than small. So here, again, we find that the delta prime equation will be less than the one that we already have. So we're going to draw that schedule to the left of the current schedule. And then we can see from this new equilibrium point that the equilibrium consumption and capital have gone down. And you're done.